All right, let's get the show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Pretty much our last in-person lecture, I think. So maybe I should actually start by talking about that. Let's see here. Okay. So you guys can see my screen. Maybe before we review, I should say a little bit about that. So it's we're coming on to finals week, so I know a lot of you are all over the place. So I just want to make sure that we all are actually. Finals week is a lot of work for me too. So I just want to make sure that we're all kind of on the same page. We know what's happening. So some announcements. Okay, so what do we have to know today? Okay, so start about with today. So things I would want you guys to start looking at today. So why is it doing that? Let's try that again. Not doing anything weird with my how I'm writing. Okay, so for today, written projects are due. I don't know why the pencil just gets thick sometimes. So midnight. So that's today's date. That's 5/4/21. What else? A mock test was posted. Will be up until I think it's 10:30 a.m. tomorrow. What else?
Do we
I think for today, that's it, right? For today. So projects, and you can start looking at the mock test. Yeah. Was there a question?
Yeah, I asked if we have to do it. The mock
If
test.
you want to do well on test 2, probably it's a good idea. It's not like something you're getting a grade for. right? I mean, you're going to get test 2 tomorrow over a 24-hour window, and it's going to be relatively similar to the mock test. So you should think of it just as extra practice on top of the homework that you guys have been doing, which is probably due today as well. I don't remember when the last homework was due.
Okay, thank you.
So tomorrow, presentations. So that's the only thing you'd have to worry about for in class. So I'm going to be recording it so that the judges, your coaches, can judge it. But of course, I'm not going to be posting that publicly. So tomorrow, you guys should come ready to present what you did in your project, and you should be prepared to like share your screen and talk about stuff you and your group. Share yourselves, share your screen, and discuss your project with the class. Remember, that's going to be 5 to 7 minutes or something like that per group. And that's all you have to worry about in class time. So presentations in class, we will have a synchronous lecture and test 2 posted to be done in a 24-hour window. So I think about 10:30, test 2 is going to come live, and it'll stay open until 10:30 the following day. Yeah, I think that's it. And of course, for finals week, stay tuned and look out for messages. So I'll want to do things like maybe set up like a review class or something. But for that, I have to figure out like a schedule when most people would be available for a review class, etc. So you'd have to just keep abreast of the announcements. Stay tuned, look out for So I think those are the main things. So today, written projects are due. Also today, for the next 24 hours, well, 24 hours and change, you can look at the mock test. Again, I would recommend that you guys actually take it seriously, practice uploading so you don't run out of time on the actual test. Upload from your phone, as I suggested to many people, it'll be a lot quicker, things of that sort. So you want to practice that. Tomorrow, it's just about presentation. You're gonna show your fancy PowerPoint chart about just giving us the basics of your project, talking about some of the ideas, how you did stuff, maybe showing us a little bit of data, a little bit of charts, stuff like that. And the lecture and the test would be done outside of class. So you'd have it like that. And then finals week, we'll just, we'll play it by ear. So we'll worry about schedules and things of that sort. I think that's all the announcements I have. Unless, are there any more questions about the plan for the next 2 days, at least? Okay. So we actually started statistics last class, and we aren't going to spend a long time on statistics, as I mentioned, pretty much about 3 lectures, right? So last lecture was the first one, today's lecture, and tomorrow's lecture, which is asynchronous. And then, so I just want to talk to you about the basics of statistics, about presenting data, some charts, central tendency, and variation, really, is the basic things I want to cover. So these are some of the things that you had to talk about in your projects even. Things like mean and standard deviation and all that stuff. So we spoke about what statistics was and why it's important. So you can get a huge clump of data. Here, it's not a lot, I just 15 data points. But you want to organize it so that you can answer some questions about it. So you can do it in a table like this, which gives you some information. You can do it in a bigger table like this, which gives you even more information. But then eventually tables can get cumbersome themselves. So we have pictures to talk about the data, right? So a lot of times, like for example, in tomorrow's presentation, a lot of you are going to have tables with like hundreds of rows in it. Like you probably don't want to be scrolling through. You might show a snippet of it, but you probably don't want to be scrolling through some huge table with hundreds of rows and multiple columns. You would want to kind of summarize the thing that you're looking at with a picture, right? And so that's where charts and graphs come in. It's just an easy way to just see the general gist of what the data is telling you. So we spoke about one picture, and that was the bar chart. And this was used for qualitative data. So remember, qualitative data is about qualities or categories or types or things of that sort, not necessarily numerical. So it could be names, letter grades, things of that sort that aren't necessarily numerical. Right? And you want to talk about statistics of such things. A bar chart is a nice way to do a picture of data like that, right? So we also learned that a good chart has a title, and it has axis labels, and it has just enough data for the reader to know what they're looking at and how to read what they're looking at. Okay, so yeah, and we just looked at one chart really. So we're going to look at some more charts here. So the next chart we want to look at is the pie chart, which, I mean, you should know what one looks like because you'll see them a lot. But I'm probably not going to ask you to actually sketch a pie chart. To do it properly, you'd need like a protractor and stuff. Like I'm not gonna do it. It's just it's too weird to the point where it's like different people would have completely different pie charts where it's going to be hard to grade. And then it's like, I can't really even grade it for accuracy at some point. It's like, well, that looks like a 10% slice to me. And someone else can say, nah, that looks like 15. Like you can't eyeball it very well, but it does show up. So you should know what it is about. So I'll just give you some quick information on that. So this again, used for qualitative data. Okay, and a circle is sliced into sectors based on relative frequency. The central degree of each slice is computed by relative frequency times 360 degrees. Right, so remember there are 360 degrees in a circle. You want to split this up into relative frequencies. So example of the above data. So we have, it was 15 students. So we can have a chart, pie chart, showing the letter grades class is pretty much going to be a circle. Okay. It's pretty much going to be a circle. And you're just going to slice it up. So, and you'll normally have a key here to tell you what each slice is about. And we'll get to that soon. But first, we have to go back to the relative frequencies. We saw there were A, B, C, D, F. And we have the relative frequencies. So A was 20%, 20%. 20% is about 1/5. Then you have 26%, then you have 20%. So about 3/5 of the circle is from A, B, and F. And then you have some other proportions for the other ones. So for example, here, so there's going to be a center in the circle, and then there's going to be one, two. So this is what I mean. I think a fifth should be a little more. 1, 2, 3. So here is the A grade, the B grade, the F grade. This is 20%. This is 20%. This is 20%. Okay. Then there's going to be another one which is a little bit more than 20%, and that was the C, I believe, 26.67. And lastly, we had D, which is 13.33. So that's a pie chart. And so the degrees at the center, like this one here, call it theta. So your theta is going to be equal to 20% times 360 degrees. That's 0.2 times 360 in degrees. And that's going to be 72 degrees. Right, so theta would be 72 degrees, right? Which if you're drawing this by hand, you'd use a protractor, but your computer will know how to measure 72 degrees. So these three here, A, B, and F, they all have 72 degrees measurement at the center. And you can similarly find the other ones. Sometimes it is color coded. So you would have over here a little key of the grades A, B, C, D, F. And you might see something like, okay, A is like green like this. And then you can have B is like blue like this. And then you can have C is like yellow like that. D is like pink like this. Let's say F is like red like this. Right? So you can have them color coded, and you'll have a key that tells you what each color means. So you don't even have to look at the numbers. So you can just see the colors, and you can kind of say, oh, A, B, and F, they're kind of similarly proportioned. C is the most, it's the biggest slice. D is the smallest slice. You can tell that. If you want a little bit more specific information, you can read it a little bit more closely and see, oh, it's 20% over here, and it's 26.67% over there. But yeah. But these are kind of annoying because you're drawing it by hand. The difference between 20% and 26.67% drawing by hand, it's going to be very hard to even notice. The only way you would really notice that the C is bigger than the A, B, and F is because the D is obviously so much smaller. So you realize that the C has to be bigger than 20%. But that's just a pie chart used for qualitative data. So now we move on to another kind of chart, which is a histogram. This is about graphing quantitative data. So it's going to look very similar to a bar graph, except the bar graph is what we use for qualitative data, which means categories, types, names, that sort of thing. A histogram is used for quantitative data, meaning a bunch of actual numerical values, right? So this could be heights, this could be dollar amounts, this could be percentages, this could be frequencies, this could be any numerical set of data. You would use a histogram to represent that. So it actually looks a lot like a bar chart, but you would except you'd have a bunch of data. So here is an example of our data. And so it's a bunch of numbers. Again, not a lot of intuition can come from this this just massive numbers here. In fact, I think I have 20 numbers here. Yeah, grades of 20 students, right? So we bumped it up from 15 to 20 students. They're just all over the place, right? So now it's not like the letter grade, which is a quality, right? I'm actually looking at the numerical grades, right? So this is actually numerical data. Now I want to represent that in a picture, right? So because it's numerical data, I wouldn't use something like a bar chart or a pie graph. I would use a histogram. And histograms work by, first of all, you can't really plot something for each data point in the same way you could do for the qualitative. What you want to do is you create bins, right? So that's what a bin is here. So it's just about ranges of data that we care about, right? So that's what a bin is. So you can have a range, and you can even have the range that is basically just a way that you would decide a quality, right? So you can have a range for which you would consider is an A, and a range for which you consider is a B, and you just want to find all numerical values that fall into that range. You can also, which is a lot more typical for a histogram, just have an equal amount, each range be an equal amount. So you can say, oh, I'm always going to dissect things by tens, right? So what you can do is you can start with a table. Make a table. To use to draw the histogram. So you would have our grades. Which here is where I'm going to put in the bins. I'm going to set up the grades in different categories. Then here we can have the frequency. And then we will have the relative frequency. Okay, so histogram plots bins versus relative frequency. So these two columns are what you care about. You calculate the frequency in order to calculate the relative frequency, right? So you would have here, let's say I wanted to group the grades by tens. I noticed that there is no grade, if I'm just glancing at this list, there's really no grade below 50, but there are grades in the 50s. So what I can do is, okay, I'll group the grades by tens starting at a minimum of 50. So I can say, okay, here's a 50 to 60. And then I can do 60 to 70. Then I can do 70 to 80. Then I can do 80 to 90. Then I can do 90 to 100. Right? I know all of these should add up to 20 grades, and I know my relative frequency should actually add up to 1, right, for 100%. And now what you can do is you can go through this list and you can count things off, right? So if I want to know how many people fall into the 50 to 60 range, I just go and I count off all the numbers that fall into the 50 or 60 range. So I would have 57, 1, 2, 3, right? Just 3. And we put that 3 here. Right? And you do that for the rest. And you'll notice here that we have 6 in this one, we have 5 in this one, we have 4 in this one, and we have 2 in this one. Just take my word for it. So if you were to go through and you count all these guys, that's how many things would be in each range. And then what you're going to do is you're going to take each of those numbers and divide by 20. So here you're going to take 3 over 20, going to take 6 over 20, going to take 5 over 20, going to take 4 over 20, going to take 2 over 20, and you're going to calculate those values. That gives you the relative frequency. Spoke about that last time. So this is about 15%. This is about 30%. This is 25%. This is 20%. This is 10%. So these are the guys you're going to be plotting. And so now what you can do is you can go talk about a histogram. Okay, and so now you can just actually put these in and right. So the test, by the way, goes all the way up to probability. So the bonus for the test is statistics, though, and you will have to draw a histogram for that. So this particular example here is important, as well as some other things that we wouldn't have covered yet, but it's bonus. That will be in the material later, which if you did the project and you really looked up the definitions of things like mean and standard deviation and stuff like that, you'll be able to do the other stuff. But yeah, a part of that the question is going to be to draw a histogram. So you need to know what you first need to do is just make a table. You need to set up your categories. You need to find the relative frequency, which you just take by finding the frequency of that individual over the total number of data points you have. So now you go and plot relative frequency. And you plot that against the bins. So on the horizontal now, you have the grade ranges. Okay. Now for us, we had 1, 2, 3, 4, 5 grade ranges. So 1, 2, 3, 4, 5. So this was the 50 to 60. 60 to 70, 70 to 80, 80 to 90, 90 to 100. Okay. And we would have things like 0.1, 0.15, 0.2, 0.25, 0.3. And so now between the 50 and 60, that was 0.15. So you have that. For 60 to 70, that was 0.3. Notice here that in the histogram, you don't have spaces between the bars, but in the bar charts, you have spaces between the bars. That's another way. You could look at the labeling of the graph to see, is it labeling by bins or categories, and you can tell a bar chart from a histogram. But another way to tell is that typically a histogram has no spaces. I should say typically, I mean, you will at times, depending on how someone wants to design something. Right, but you just continue. So it's very similar to doing a bar graph. You still plot relative frequency, but here it's numerical data that you're putting into bins. So for 70 to 80, we had 25%. For 80 to 90, we had 20%. For 90 to 100, we had 10%. Okay, and that's your bar graph. And of course, you can color it, you can do whatever. Make it look fancy, whatever you want. But at this point, that's the histogram. So very, very similar to a bar graph, except it's based on the type of data that you're plotting. You use a bar graph when you're plotting qualities, and you use a histogram when you're plotting quantities. I should mention that sometimes bins are labeled with the middle value in the bin. So that would look like so here you might have labeled this 55, 65, 75, 85, and 95, right? But it would be known that, oh, you're just spreading out 5 units on either side of these values, right? They'll just tell you the middle value. So that's typical or common enough. So a histogram, you can use a histogram to come up with something called a line graph. Right? And here's how that would work. right? So what you can do is you can go to each bar. You can actually see what the highest, the middle value of the bar is. So you can go in, you can put a point here, point here, point here, point here, point here, and you can connect these with a line. Right. So put a point at the top and middle of each bar and connect with a line. Connect successive points with line segments. And so that would lead to so this leads to if I can do this. No, that's not the one I wanted to copy. This one. All right, let's see. So you get a line graph when you like get rid of the bars. Right? And so this is a line graph of the 20 grades. Now, a line graph, it's sometimes called a frequency polygon because you actually create a polygon, you might notice. So it's when you really start to focus on this shape here. So this is going to be a straight line. That's 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 a straight line. And then that is a straight line. So you create like this polygon that looks like that. Right. So, and that's called this is called a frequency curve. Or frequency polygon. Of the 20 grades. Right. It's pretty much exactly the line graph, except when you think of this as just one big object, right? Not just a line, you think of it as an object. You would shade this all in. It's called a frequency polygon. So it's when you're looking at the data as like a mass, how it's shaped, what's filled in. Okay. Now, the line graph and the frequency polygon give rise to another notion, which is very important. That's the notion of shape, right? So from here, you can start to talk about the shape of a data. right? So you like this, it's a shape, right? And different data sets will have different shapes to them. Some might be very skinny, some might be very blobby. You'd have shape to data, right? So you can go from a list of numbers, which we had up here, to like a shape, right? Now, some shapes are very, very important. Things like a bell shape is a very common thing to come up. This is often called things like a normal distribution, which we're not going to talk about, which is very weird. Like they have us talk about Bernoulli trials and binomial distribution in statistics, but they never get to the normal distribution in our syllabus, which I feel like it's pointless. Like we did talk about binomial distributions, but that's in the probability section. How binomial distributions relate to statistics is because they can be used to approximate bell curves and normal distributions, but we're not touching on that apparently. So I'm not even sure what I'm going to say more about that. But yeah, so this gives you like a shape, right? And that actually leads you to the idea of an average, right? Which is what the next section is about. Right? Measuring averages. So this is the last thing we're going to do today. And it's not going to be difficult, I don't think. It's a lot of things that you guys are probably aware of already, but it comes from this idea of shape, right? So one thing you'll notice, and I'm not sure why that one is capitalized. Fix it later. I don't know what happened there. Doesn't even make any sense. Shape of the frequency curve in the last example has a noticeable property. Hopefully it was noticeable. Something you might notice is that it has a peak. In the last example of the last section. Okay. It has a noticeable property. Hopefully you realize that there was like a peak. There's like a highest point. There's like a tip of the mountain, right? And it has one peak. It's possible that your mountain would have a couple peaks, but this particular mountain has one peak, right? And so what you can interpret that as is that's like the typical value. That's where most people kind of end up, right? You'll notice that in this chart, basically what I'm saying is what you can tell from this picture is that most people in this class got a grade between 60 and 70. Now, if you remember what the goal of statistics was, is to actually be able to do that, predict what would happen in a typical scenario, right? Is smoking good for you? Well, what typically happens when someone smokes 2 packs a day? That would be how you would answer that question. You can't answer it for every particular individual, but you can see like overall, like how does this affect us, right? So the typical value is a very important thing that we'd want to know about. And that leads to the idea of central tendency, right? So the central tendency, as you can see here, is a measure of what the typical value is, okay? So in this particular example, in the last case, the typical value was somewhere between 60 and 70. Most students got a grade between 60 and 70. So if you were to have to guess for someone, okay, if you join this class, what grade are you gonna get? I'd probably guess you're gonna get somewhere between a 60 and 70 because most people get between a 60 and 70. So is it true that they would definitely get between a 60 and 70? Well, no, because there are people who got other grades. But if you were to just guess for a random person, not knowing about their experience or anything, and you had to just say, well, what would typically happen to a person who goes into this particular class? Well, I would guess that they would get a 60 and 70. right? And so that's the same way in which we would say, well, what would happen to a person who smokes 2 packs a day for 60 years? Well, this is where they would tend to end up. They don't have to end up there guaranteed. They can end up better or worse, but this is typically where they're going to end up, right? So that is central tendency. And you see this from a graph from where the peaks are, where data points seem to clump together, right? So central tendency is the tendency of data to clump together in this way, right? And then there's the notion of an average. Now, an average is just a numerical measure of central tendency, right? You'd want to know what is the numerical value where things clump around, right? That is an average. And there are many kinds of averages, but we only care about 3 of them. There's the mean, the mode, and the median. And the mean, very popular one. We all kind of know what this is. We've all used this before. We're all very used to this when calculating our grades and stuff, like my average grade in the class or whatever, is the sum of all the data points divided by the number of data points there are. So that's the one with a very nice equation that describes it. It's also a very typical average to use. Most people, when they use the word average, they're talking about the mean, right? But technically, average does not have to be the mean. Although in everyday language, when someone says, oh, the average grade was blah, they tend to be talking about the mean. Or the average this is blah, they tend to be talking about the mean, right? They really should say the mean grade was blah, but almost no one says that because the mean is a very typical average to use. It works out in a lot of situations. Particularly the mean, as I mentioned here, it works very well for bell-shaped data or symmetric data. And it just so happens that many things in life, many phenomena in life are approximately bell-shaped if you start plotting the data out, right? You plot the heights of men between 20 and 30, you'll end up getting like a bell shape. There'll be like an average height, and then everyone kind of slides off to the right and to the left of that. Very tall people are very few, very short people are very few. So you get this kind of bell shape, right? And a lot of things in life have that shape. So the mean is a very common average to use, which is why a lot of people, when they say average, they really mean mean. It's because it's such a typical thing to use. Everyone just kind of thinks of average as a mean, but it's not. There are many kinds of averages. Another kind of average is the mode. And this is just simply the guy. There's no real equation for this. This is just the guy who shows up most of the time. Count the guy who shows up most often, that's the mode. Count several guys, you can have several of these guys. You can have several central values, but the mode is the average of the most frequent. So again, if you realize that in a certain situation, 99 people got a score of 80, and then you had one person get a score of 100, and someone asks you, what is the typical value? You would say 90, right? Like 99 people got that grade, and then this one person was the outlier, right? So it's like, you shouldn't even consider that person. Like 90 is where we want to be. So that's where the mode would come in handy. It's when you really have a value in your data set that hugely overwhelms all other values to the point where you probably don't even want to think about the other values as being possibilities. It's so unlikely you'll get them. Median is another important one. And this is just when you arrange the data set in order, you pick out the middle value. So if you have an odd number of data sets, there will be a middle value. So if you have 5 numbers, the middle value would be the 3rd number. If you have an even number, say 6 values, then the median is defined to be the mean average of the 2 middle values. So it'll be the average of the 3rd and the 4th data point, okay? And I feel like you guys have computed these a lot before, so it's probably just a refresher for you guys. Now, you might think of the median as a very strange way to look at averages, but it turns out that there are a lot of situations in which this would be useful. For example, with salaries, right? If you look up what is the typical salary of some position that you're interested in, you'll always notice that they give you the median salary. They never tell you the mean salary. And this is because there are outliers that can be typical, but they skew the data so much. So you can have a company where you have a bunch of interns and you have a bunch of entry-level workers, then you have a bunch of middle management, then you have the CEOs and the executives. And the CEOs and executives, their salaries are so huge that if you were to find the mean, if you were to tell the mean average salary, it would skew so much to the CEOs Because you have this kid over here making $30,000 a year, and you have this dude over here making $2 million a year. If you find the average of those two values, it's going to be like $1.5 million, which is not typical at all. You have way more people earning 30,000 than you have people earning $1.5 million or 2 million. So yeah, you wouldn't want to choose. You would want to choose the median in situations like that. By the way, grades of a class, a median is also a useful value to use. So you can calculate the mean, mode, and median of these guys. Just quickly going through it. So the mean here would be 2 plus 3 plus 2 plus 15 plus 12 plus 9 plus 8 plus 12 plus 6 plus 3 all over. And there were 10 values here. So that's 8.2. So if I wanted to say the typical value according to the mean of this data set is 8.2, and that would just be where I would guess most people to end up. You'll end up around a score of an 8.2. Now you could score as low as a 2, you could score as high as a 15, but on the mean average, around an 8.2, give or take, right? You can also talk about the mode here. That's the value that shows up the most often. If you start to count the data points, you will notice that 12 shows up the most often. You have 2 people getting a 12. So that would show up the most often. If you look at median, you would first have to arrange the values in ascending order. You could also do descending, but it's usually ascending. So you would just rewrite this in ascending order. So that would be 2, 3, 3. Did I have 2 3s? I did have 2 3s. So the mode was 12 and 3. You can have several. 2, 3, 3, 6, 8, 9, 12, 12, 12. Oh no, there were 3 12s. Did I miss a 12? Oh, I think I missed a 12. That's why. That first number was supposed to be a 12. But you could have several, but in this case, there was only one. 12 shows up 3 times more than any other. So there's 12, 12, 12, and then a 15. And then there were 10 numbers. So what you do is you find the 2 middle numbers. In this case, that's going to be the 5th and the 6th number. And you find the mean of these. So it's 8 plus 9 over 2. And you would get 8.5. Right, so that's pretty much central tendency and averages. You only have to know those 3. But yeah, I mean, I don't think that would be strange to any of you. I feel like these are things you calculate all the time or have seen before, especially the mean. So next time we're going to talk about, well, probably not synchronously, variation or the spread of data and what this actually means, right? So that's where we're going to talk about things like standard deviation and things of that sort. And then I will talk about some other graphs that can come up here. And our statistics talk is pretty much going to end right there, just enough for you to kind of interpret data. But yeah, so that's all I have for you today. Remember the announcements that I mentioned at the beginning of class, and nothing more to say today, I don't think. So we'll stop there. Enjoy your day. Remember, you should send me your written projects later, and I will see you guys in the next one.